All right, guys, so we're going to start with our family tree. The reason I call this, it's called the quadrilateral family tree, because it's all the different types of quadrilaterals and how they relate. This family tree kind of shows you how they relate. You know, you either have parallelograms or they're not. And then, you know, different types of parallelograms. It could be a rectangle, it could be rhombus, it could be a rectangle and a rhombus, and you would call it a square. So it kind of shows you all of their relationships. This is what we're going to be working with all week. So we're going to start here every day, and by the end of the week, we'll have this all filled in, and we'll understand all the different types of quadrilaterals. So let's start with definition of quadrilateral. It just requires 4 sides. And you don't have to draw this, but what I mean by that is if I drew something like this, the only thing you could tell me is it's a quadrilateral, right? You don't know anything about the sides, you don't know anything about their measurements. The only thing you can tell me is it's a quadrilateral, it has 4 sides. All right. Today we're going to learn about parallelograms. The reason it's called a parallelogram is because it has 2 pairs. We're going to write this by definition. 2 pairs of parallel sides. Parallel sides. Sorry about my handwriting. It's a little hard to write on this. And then there's 4 properties about parallelograms. So 4 things, if they tell you it's a parallelogram or if they mark parallel sides, then there's lots of stuff that you can say. You can tell me opposite sides are congruent. I'm going to use this symbol for congruent. All right, opposite sides are congruent. So if this was a parallelogram, you know this side is the same as this side. If this was an 8, this is an 8. Opposite sides are congruent. Also opposite angles. Opposite angles are congruent. Angles are congruent. So again, and you don't have to draw these, I'm just kind of showing you examples as we go. If I tell you that this angle is 50, you can tell me that this angle is 50. Opposite angles are congruent. So opposite sides are congruent and opposite angles are congruent. Then we have consecutive angles. Remember that was same side interior. Consecutive angles are supplementary. And I really didn't have to tell you this because as soon as I said parallel lines, oops, I can't talk and write, are supplementary, they add up to 180. As soon as I tell you parallel lines, so as soon as I say parallel lines, you know parallel lines cut by a transversal, same side interior should add up to 180. So same side interior should add up to 180. Consecutive angles add up to 180. And then last but not least, your diagonals bisect each other. Your diagonals bisect each other. I don't know why I put an S there. Bisect each other. So what does that look like? So a diagonal goes corner to corner. So what it's telling you is that this diagonal is bisected. It's created 2 equal pieces. So if this is 8, you know this is 8. Right? If this is 5, you know this one's 5. Just this little piece, right? You know the diagonals are bisected. They're cut into 2 equal pieces. All right? So these are 4 things that are really going to help you when you're dealing with parallelograms. But you have to know you're dealing with parallelograms first. So now I want to travel to the 4.1 worksheet. Again, this is just for me to show you some examples. So this is still considered notes. Still considered notes right now. So let's do a couple of examples here. This gives you, again, for each parallelogram, it's not going to let me draw. So they tell you it's a parallelogram. They tell you it's a parallelogram. Find the missing sides or angles. So we're going to use everything we know, right? If this is 8, the opposite sides are equal. That's 8. If this is 10, opposite sides are equal. That's 10. If this is 62, opposite angles are equal. That's 62. How do I find A and C? Remember, consecutive angles should be supplementary. So 180 minus 62. See all that math I'm showing? There's not a huge amount of work to show, but I want to see whatever math you do to get 118. So that means angle A is 118. Opposite angles are equal, so angle C is 118. And if you remember quadrilaterals, all four angles should add up to 360 every time. And you can fill this part out. AB is 8, AD is 10, angle A is 118, angle D is 62. We already kind of filled it all out. 62 degrees, 118 degrees, sorry. Let's skip around a little bit. How about we try number 3? So it is very, very tempting to say, oh, this is 56, this must be 56. Please don't. Okay, please don't. That is nothing. That is not on our quadrilateral family tree. Nowhere in there does it say that angle is bisected by a diagonal. It says diagonals bisect each other, so the diagonals are two equal pieces, not the angles. Okay, it does not bisect the angles. So just because this one's 56 does not make this one 56. So I want you to keep that in mind. But we still have opposite angles are equal, so B is 83. Now what? Right? Now what? What do I do? Well, I see a triangle here. I see a triangle here. See all this lovely math? We know a triangle adds up to 180. We can subtract out 56 and 83. See all this beautiful math? I want to see it. Okay, don't just write answers down. If you did math to get there, I want to see it. And I got 41 degrees. All right, so we got that one. And then we're kind of stuck, right? But then we remember parallelogram has parallel sides. Cut by a transversal, alternate interior are equal. Alternate interior are equal. So you can use the parallel sides cut by the transversal as well. So DCA is 41 degrees. CAD is 56 degrees. And CBA is 83 degrees. That's a degree symbol. So notice how I don't even look at these. I just fill out as much as I can on my picture, and then I go back and say, okay, what did I want to answer, right? What did I want to do? Let's do a couple from this page. Again, I'm just jumping around because I'm using these as examples. These are kind of like notes. So here, DAB is this whole angle right here is 80 degrees. They want ABC. They want this angle right here. Well, you know that these are consecutive. They should add up to 180. So, 180 minus 80 leaves me with 100. Right? I want to see the work. If you did math, I want to see the work. If they're equal, there's no work. ADC is this angle right here, is 127 degrees. And they want to know CBA. They want to know this angle. All right, not much work to show here. Opposite angles are equal. 127 degrees. That's a 2. 127 degrees. Opposite angles are equal. So not much work to show on that. This one, DE. So this is actually not an angle. This is a line segment, right? This line segment is 6. They want to know what EB is. Remember, diagonals bisect each other, so you know this piece is the same as this piece. So if this is 6, this is 6. EB is 6. DB is 6 plus 6. 6 plus 6 is 12. All right. Now, just so you understand, we don't know anything about AC, right? We know that AE is the same as EC, but we don't know their lengths until they put it on there, okay? DC is 14. What's AB? Opposite sides are equal. AB is 14, okay? And then let's go ahead and do number 9. AD is 3x plus 6. and BC is x plus 18. Right? These are sides. These are opposite sides. We know opposite sides are equal. Set them equal. Opposite sides are equal. Set them equal. Let's subtract x from both sides. So we've got 18, 3x is minus 1x, 2x plus 6. We're going to subtract 6 from both sides. So we got 12. And divide both sides by 2. So it says x equals 6. And then they wanted AD. AD. We got to go and plug it back in. 3 times 6 plus 6. So 18 plus 6 is 24. Which means BC is 24. So I feel like we're getting the hang of it, hopefully by now, using all those different pieces. Let's do the last one here. CDB is 30. And DBC is 40. Oh, my handwriting's awful in here. And we want to know DBA and DAB. All right, so let's try it out. So here again, parallel lines cut by a transversal. Let's kind of sketch it out here. Parallel lines cut by a transversal. Alternate interior are equal. Alternate interior are equal. All right, so we know this whole angle is 70 degrees. We know this whole angle is 70 degrees. They wanted DBA. Oh, we just found it, 30. All right, DBA is 30. And then they also wanted DAB. They want this whole angle. Huh. So I know this is 70. All right, and these are consecutive. They should add up to 180. So 180 minus 70 leaves me with 110 degrees. So we know this angle is 110. We know this angle is 110. All right, so that's what you're using. You're going to use this family tree, use those properties, whether it's the definition or one of the properties, use those to set it up. If you see consecutive angles, add them up to 180. So when you're working on this worksheet, I know you'll get down here where there's some equations. There's some equations here. Ask yourself, are they, like number 11, are they consecutive? Should they add up to equal 180? Or are they opposite sides? Should they be equal? That's what you should be focusing on. All right, so get this worksheet done and submit this worksheet. And tomorrow we'll pick back up on that family tree, and we'll do rectangles, rhombus, and squares.